And we are recording.
We are good? Okay.
We are go.
So we have our toy organ circuit here being controlled by the lab jack, or the lab jack. So anyway, I just want to do a quick demonstration of our circuit actually working. So
come on, little camera.
Yeah,
oh, hey.
What we're going to be doing is playing this song right here. These are
so difficult to see.
Yeah, this is the track that controls each note, and so we'll go into detail later. But let's actually hear the song that we're going to play. And so, listen closely. Here we go. All right, go ahead. Okay, so that was our song. So this is how our circuit works. Wade, do you want to talk about this?
All right. So here at the input of our circuit, we made a few true-false tables, although we could have just used true and any other letter. But anyway, what this is this is when and what is played for the duration of our song. You can see we have 4 of these because on our circuit we have 4 different capacitance switches that we're playing with the lab jack outputs. But each time a true is compared in here, this is a script comparator, then it'll output and it'll turn on with our easy digital output of the lab jack. This one controls channel 0, channel 1, channel 2, channel 3. These little green switches here, these are LEDs, which shows up in our front panel. The LEDs will turn on each time one of the switches is engaged. And you can see we've got this all in a while loop. There's a counter there for 300 milliseconds. And this little orange thing that goes across is our, what is it? A shift register.
Mm-hmm.
And we put this 0 here, so that way it started over at 0 each time we recorded. And then we did a little bit, there's a plus 1, so each time it runs through, it adds 1 to itself, and then runs again. And
like a counter.
And using this shift register for each of these comparisons, the first time it cycles through, it'll select the first letter, and then it'll display the switches as it sees. And then after the shift register goes through one time, it'll check the second digit, and then the third digit, and then the fourth digit. And it'll continue doing that until it gets to the this number is greater than 54, and then it'll just turn off. So there's how it works.
Alright, and then so that's the software side. Now these LEDs, that's not all we're doing. We're actually controlling our toy organ circuit right here. And how the computer does this is we use the lab jack and the easy digital outputs to control the controls of the quad bilateral switch. And so there are 4 switches in this little chip, and when you apply 5 volts to the control pin, it will close the circuit and play the tone. Am I missing anything?
Oh yeah, well, one of the problems we had with this circuit is these quad bilateral switches. We kept on burning ours out. That was either because these things weren't meant to be ran on 9 volts, or we were manhandling them, or maybe
soldering stuff to them.
Oh yes, well, you know, that was only the second one. We got a broken switch, and we decided to try to solder it to see if maybe we could get it to work, but to no avail. Anyway, but we finally got a working quad bilateral switch, and it's hooked up with this mess of wires here.
Which I think is a very clean job, actually.
Oh, yes, yes. Of course, Dwight did that part, didn't he?
The rest of our circuit is, you saw last time.
Oh, I just remembered something.
Oh, cool.
That 9 volts, we were running our circuit on 9 volts.
Oh, good point.
And we couldn't get our switch to work for quite some time. Like, the LabJack only outputs 5 volts, and if we put 5 volts in the controlling circuit, that wasn't enough to turn the circuit off all the way. So we dropped our entire circuit down to 5 volts, and it worked just fine. So there we are.
Alright, so here is the wonderful abstraction of our circuit. So starting at the beginning, our circuit plays music. Alright, that's what it does, or that's what we want it to do. Anyway, so starting at the beginning, we need to input a song file. And so this is kind of what that is. We have 4 strings, which correspond to the 4 notes that our organ can play. And there's 2 values available. There's true and there's false. True being the tone is on, false being the tone is off. So anyway, the program reads these one at a time, chink, 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 and this is all processed in the LabVIEW program. So the LabVIEW program controls the LabJack, and the LabJack has available 4 digital outputs, which are either ground or +5 volts.
It also has some ground circuits.
Okay, yeah, that too. Anyway, you feed the ground or +5 volts to the quad bilateral switch that has 4 switches in it, which correspond to the 4 notes that our tone generator circuit can play. So when we feed 5 volts in, when we output 5 volts on this switch, it'll play one of our notes. And so we change these based on these truth values to get a song. Alright, Wade, tell me about...
I want to catch pregnancy.
Tell me about the opto-isolator and how it didn't work.
The opto-isolator is a piece of crap. No, I'm kidding. No, the opto-isolator does not work for our LabJack. The reason why is we don't have enough power. If we have enough voltage, we don't have enough current, which means we don't have enough power.
Nice distinction.
Yeah, it's very distinct, isn't it?
Yeah.
So, yeah, after fiddling around for 15 minutes on the opto-isolator, and the reason I played with the opto-isolator was so that way maybe I could power a relay. But, yeah, after playing around for 15 minutes, I realized that whatever pinout I had didn't work, or I didn't have enough power. Something was wrong. So I nixed the opto-isolator idea, and we went on with our quad bilateral switch. Dwight, tell us about the quad bilateral switch.
Alright, so that switch is a pain in the butt. It's really sensitive and you can blow it out very easily. No one? Okay. So there was an issue with how we were going to power it. We were attempting to power it with 9 volts. However, the LabJack only puts out ground or 5 volts. And this caused a problem because the voltage that we were using to turn the switch on was out of the range of the power voltage of how we were powering the chip.
So we were using 9 volts.
Yeah. So what we did is we dropped the whole circuit down to 5 volts, which worked fine, and therefore our chip was happy. And it switched on and off when we applied 5 volts to each switch.
All right.
Alright, Wade, what did our circuit accomplish?
Our circuit is capable of reproducing musical composition over and over and over again.
Thank you.
Just hit the start button. Hit the start button. Do it. Hit play. Come on. Go.